Hey, my dear NEET warriors, welcome to the Basic Maths Class 11th NEET chapter. And today we are going to see some amazing graphs. We are going to, in fact, have lots and lots of fun in this session because graphs are visual. You can see them, you can also feel the graphs. And graphs are one thing which, give you a very good understanding of what is happening in physics or chemistry. Why these charts, be it pressure volume, be it distance time, be it acceleration time, be it velocity versus force, anything. So the graphs give you the information in a very condensed form, and you can know many different characteristics of that body or that particular system, right? So graphs are a fun way to actually interpret different things which are there around us. So let's actually see different types of graphs. Let's see the equations, let's see the graphs, let's see how is it relevant to us and all of that. Hello Mohana, hello Archie, Akash, MS Lakshmi, welcome Karthikeyan, welcome Madan, welcome Dishonesty 71. Wow. Hello Asha, good evening my dear warriors. And have you marked your attendance yet? And if you haven't marked your attendance, so you might be wondering, how do I mark my attendance? Well, that's the like button, guys. Make sure you do that. It also supports me as well as the channel. And if you're not yet tuned into our channel, make sure you hit the subscribe button, because this is one-stop solution for all your NEET requirements, right from preparation to strategy to announcements to news to counseling to every bit and piece of information. Okay, so my name is Captain Shreyas. I've been teaching for more than 13 years and have produced top 2-digit ranks in JEE Advanced, JEE Mains, NEET, and I'm very glad and happy that many of my kids right now are doctors and really good engineers. So let's begin the fun session, guys, of graphs. Just to give you a brief roundup. Thank you guys for that like and the hearts out there. Thank you so much, Deva. Thank you so much. I'm very good, Lone. Nice to see you after a long time. Hello, Akansha. Nice to see you guys after a long time. Attendance mark, Sundaram. Thank you so much. Hello, Rupa. Hello. Yes is the Avenger out here. So just quickly doing a small recap, right? Your coordinate axis that you have tell you the three different directions in space. One is, let's say, in the horizontal direction, one is, let's say, in the vertical direction, one is, let's say, in the inside out direction. So you have the three axes, and you also have the three important planes. One is, let's say, this is ZY plane, let's say this is XY plane, let's say this is XZ plane. So I have marked the planes also over here. The nomenclature goes with the axis which are there in that plane, like the plane of the board. Come on, my dear warriors, which plane is this? The plane of the board is which plane? Is it XZ, is it ZY, or is it something else, XY? Come on, my dear warriors. Yep, it is ZY plane. Very good, guys. Awesome. No, there is no, whenever you mention the plane, there are always two alphabets, which those two alphabets are the axis which contain that plane. Y-axis and Z-axis, correcto. O is called as the origin. So these are the standard things which you should know. Now, you might have heard this concept called as slope, and often people get confused what this slope is. So let me talk about it little bit briefly over here, and then we will go to the equation of line, parabola, cubic, and sine and log, and so many other things, guys, which you're going to see. Okay, so the meaning of that word slope. What is the meaning of that word slope? Slope is basically nothing but the steepness. How steep that graph is. Now, if that slope is positive, that means it is like this. It's basically going upward. If that slope is negative, that means it is basically going downward. And by chance, if it is zero, that means it is flat like this. So it is basically horizontal. It is basically horizontal. Is that clear, guys? It is basically horizontal. It's neither going up nor it is going down. If it is more positive, that means it has more steepness. If it is more negative, that means it is going down further. So, my dear students, if I tell you there is a graph which is going down and this has a slope of minus 2.2 example, then a graph which has a slope of minus 3, a graph which has a slope of minus 3, will it be here or will it be here? Will it be here or will it be more down? Minus 3 is more negative, so hence that graph will be something like this. So this is minus 3. Is that clear, my dear students? Is that understood, my dear students? Very good. And the symbol for slope, generally in most of the books, you will see it is basically M. What is it, my dear warriors? It is basically M. Very good. Now, to talk further about slope, see guys, imagine I have a graph like this. A graph like this. This is a straight line. This is basically a straight line. What do you think? Will it have a constant slope or increasing slope or decreasing slope? Let me know in the chat box. Quickly. Will this green line have an increasing slope, constant slope or decreasing slope? Come on, put it up in the chat box, guys. I want to see what your answer is. Whether I am here or here or here or here, the upwardness, the steepness is the same. It is not going further up or further down. So my dear warriors, what can I say? The value of M is basically a constant one. The value of M is definitely a constant one. Everybody, lot of you said increasing. That is a wrong answer. Slope is not increasing. In fact, it is a positive constant. It is a positive constant like plus 3 or plus 4. Slope is not increasing. The value is increasing. There is a difference, guys. Here the value is only this much. Here the value is more. Here the value is even more. Value, the value of that graph is increasing. Yes, that is correct. But slope is not increasing. Is that understood? Lot of you got clean bold, na? I bold nicely, direct hit on the stumps, or maybe LBW, gone out. So many of you said increasing. That is not the correct answer. But let's say, my dear students, if I have a graph which is like this, what do you suggest? Is this having a constant slope? Is this graph having a constant slope? I doubt so. Here it is less steep, here it is more steep, here it is even more steep. It is becoming more and more positive. More and more positive. That means the slope is increasing. Slope is increasing. Is that clear? Very good. Here the slope is not constant. Here the slope is increasing. It is becoming more and more positive. Similarly, my dear warriors, if I draw a graph like this, do you see over here what is happening? Here it is more steep, less steep, less steep. Slowly it is becoming flat. So can I say it is becoming less and less positive? Less and less positive. So can I say basically the slope is decreasing. The value of the slope is decreasing. Is that clear? Okay, very good. It is not constant in this case. So only for a straight line the slope is constant. Everybody has this registered in your head. Only for a straight line the slope is constant. For any curved line the slope might be increasing, decreasing, could be anything. Basically it will not be constant. Keep this in mind. Okay, I hope this is clear. Why positive? Because it is going up. Look at this. This is going up, up, up. Yeah, it is going down later on, but right now it is going up, no? So that is why it is positive. So maybe the slope was plus 4 here. It will become plus 3. Maybe it is becoming plus 2. Maybe it is becoming plus 1. So it is positive because you can see it is going up. It's increasing. So that's the reason why it is going up. Is that clear, Dr. Srinidhi? A lot of students tell that the slope is negative in this case. So those people are wrong. That's the reason why I gave this question, because many students make a mistake in these kind of questions, guys. So imagine, my dear warriors, if I have the axis like this is x-axis, this is y-axis, this is the origin, and if I have a straight line over here, then the slope of that particular line, which is basically m, is given by the following. How is it given? You see where it intersects the x-axis, measure that angle. Let's say that angle is theta. You see where that line intersects the x-axis, measure that angle, let's say it is theta, then the value of the slope is basically tan theta. Basically it is tan theta. You can also write it like this. You can also further write it like this. If you take a point here and if you take a point here, let's say this is point 1, let's say this is point 2. This point will have some coordinate, x coordinate, y coordinate, correct? This will have some y coordinate, this will have some x coordinate, this point will have some y coordinate, some x coordinate. What do you think this will be? What do you think this length will be? From here to here, the difference of their x coordinate. This is x2, this is x1. If this is x2, then this is x1. So what is this? The difference of the x coordinate, that means delta x, guys. That means this is delta x, my dear warriors, correct? Similarly, what will this height be? Think about it. If this is y1 coordinate, this will be y2 coordinate. y2 minus y1 is this height. So it is the difference of the y coordinates. That means it should be delta y, my dear warriors. Correct? Yes or no? Everybody with me? Awesome. If this is theta, if this angle is theta, guys, think about it. The same angle will continue because this line and this line are parallel. It is the same green line. So even this angle will be theta. So tan theta, my dear students, tan theta is opposite. Tan theta is nothing but opposite by adjacent. So over here, opposite is delta y, adjacent is delta x. So you can also write it as y2 minus y1 upon x2 minus x1. Is that clear? Is that clear? This is the value of the slope of a straight line, slope of a line in general. Tan theta, or basically delta y by delta x. Very good, guys. Awesomeness. Now I will go slightly more further, guys. I'll go slightly more further over here. If I have a random curve, and I want to find the slope at any point, because here I know that the value of the slope is not a constant. So if I want to find the slope at any point, just draw a tangent. What do you draw, my dear students? You draw a tangent at that particular point, see where it intersects, measure the theta. So the value of the instantaneous slope at that particular point will be tan of that particular theta. It will be tan of that particular theta for that tangent. Remember, if you draw a tangent somewhere else, the slope will be different. If you draw a tangent here, the slope will be different. If you draw a tangent here, slope will be different. If you draw a tangent here, the slope will be different. So the slope is changing. You take any point where you want to find the slope, just draw the tangent, see where it intersects the x-axis. That's it. That will give you the answer. In calculus, in derivatives, this also is redefined, or it is rewritten like this, where it is a straight line, it is delta y by delta x. So guys, when it is not a straight line, when it is curved, when it is varying, the delta will become small. The delta will become small, and instead of delta, what do I write? Put it up in the chat box. What do I write? Come on, guys. Think about it. Yes, instead of delta, I will write dy. Instead of delta x, I will write dx. So basically the derivative. This is basically your derivative. Keep this in mind, my dear warriors. Very good. Excellent. Logeshwaran M, y2 minus y1. This coordinate minus this coordinate. y2 is this entire height. y1 is this height. So how much will this be? This whole thing minus this will be that remaining delta y. Same thing, how much will this be? This will be this whole thing, which is x2 minus x1. So delta means change. So one thing minus the other thing. That delta means change. So one thing minus the other thing. And you can see here in this particular right angle triangle, opposite side is delta y, adjacent side is delta x. That's the reason for that. I hope this is very, very clear. Awesomeness. So that is dy by dx, that's for a straight line. Awesome. Now let us go to some graphs. Now that you understand this word slope, you understand the word instantaneous slope, let's go to the graph part. First, let's talk about straight lines, my dear warriors. Straight lines is the most important thing. Straight lines is the most important thing. So let's say, for example, this is your x-axis, this is origin, this is y-axis. And if I have a straight line which goes like this, wherever it hits the y-axis, that height is called C, which is also known as y-intercept. Y-intercept. The slope of that particular line is m. Then you take any point on that line. You take any point on that line. If it has some y coordinate and x coordinate, then this y is nothing but mx plus c. M times x plus c. This is the equation of your straight line, yes or no? Y is any point, y coordinate, x is any that particular point's x coordinate, m is the slope, c is where it hits the y-axis. So if I give you an example of this and tell you y is equal to 7x minus 2. Y is equal to 7x minus 2. What will you imagine, guys? You will imagine x-axis and y-axis. Minus 2 means below. So you will take a point minus 2 below, right? 7 is positive, but it is a very big number, much more than 1. So the slope is positive. That means it is going up and it is going through this point. So the graph or the line equation will look like this. This is that line. Agree? Everybody is able to visualize? Everybody is able to visualize? Very good. Let's take another example. Let's say I give you velocity is, let's say, minus 3 plus 5t. Minus 3 plus 5t. Or let's say I put minus 3 minus 5t. Minus 5t. Now, if I have to draw a graph, instead of y and x, I will draw velocity and time over here. Velocity and time over here. Do you notice this is like c, this is like m, this is like x, this is like y. Correct? Y is equal to mx plus c. C is negative. That means you have to go below. So this is minus 3, guys. This is minus 3. Slope is also negative. That means it is going down. So definitely it will go down like this. Definitely the graph will go down like this. Is that clear, my dear warriors? Understood or clear? Crystal clear? So any equation you get, now you know how the graph will look like. 100%. Very nice. Now that we have spoken about a straight line, okay, let us talk about the next line, and that is basically imagine y is equal to ax square plus bx plus c. What kind of equation is this? What kind of equation is this? Come on, my dear warriors, this is nothing but a quadratic equation. And the moment you have a quadratic equation, my dear students, what will happen is that the graph becomes a beautiful curve called as parabola. Called as parabola. This shape is called parabola. Everybody with me? Now, whether the graph will be up, down, like this, all that is decided by these variables. These variables decided. How? Observe. If by chance A is positive, then the graph is upward parabola. Then the graph is upward parabola. If by chance this value of A is negative, then it is like this. it is basically a downward parabola. It is a downward parabola. Not just that, my dear students, one more thing that you can see, this point where it hits the y-axis, this height, can you guess what is this height? Wherever it hits the y-axis, the intercept on the y-axis, what is that value in terms of A, B or C? Come on, put it up. Everybody put it up. What do you think that particular value is going to be, guys? Yep, this value is basically your C value. If this C is higher, then the graph goes up. If this C is 0, it will pass through origin. If the C is negative, it will go from below. It will go from below. Exactly. And one last thing over here is the roots. If the discriminant, which is there, which is b square minus 4ac, if the discriminant is more than 0, then you will see that the graph will intersect two times. But if by chance the discriminant is 0, then you will see that the graph will not intersect two times. It will only just touch it once and go. And the other case, if discriminant is less than 0, my dear warriors, then you will see it will never touch the x-axis. It will just go above it. Keep this in mind. So these are the things that you should keep in mind while drawing quadratic equations graphs, which is nothing but a parabola. So let me give you an example and see if you are able to figure out the graph of this example. Imagine I have a graph, or I want to draw a graph of y is equal to 2x square minus 3x minus 4. Example. This is the graph which I have to draw. Understand over here, this value of 2 is A, the value of B is minus 3, the value of C is minus 4. So one thing I know because C is negative, in that graph of y versus x, that graph will definitely pass through this point minus 4, 100%. It will definitely pass through minus 4. Everybody with me? Great. Next, because A is positive, that means it is upward parabola. So it will pass through this. It will definitely pass through this. Now let's talk about the roots. Are the roots there or not there? Find the value of discriminant. B square minus 4ac. So minus 3 square minus 4 into A, which is 2, into C, which is minus 4. So minus 3's square is 9. Minus will become plus. 4 4s are 16. 16 2s are nothing but 32, my dear students. So this is 41, which is basically positive. Positive means it will hit two times. So hence, my dear students, the graph of this particular equation will look something like this. This is one point and this is the second point. Is that clear how we drew the graph? Did you understand how we drew the graph? Everyone with me? Clear? Understood? So this is how you analyze. Come on, one more question. Quickly you try to do this particular question, my dear students. Example is y is equal to minus 3x square plus 2x plus or let's say minus 1. Okay, this is the equation. I want to draw the graph. Let's analyze this really quick. Come on, think about it. I will draw the y-axis, I will draw the x-axis. I can see that the value of C over here is minus 1. That means it should definitely pass from minus 1. The value of A over here is negative. That means it should be a downward parabola. Then the value of the discriminant is B square, which is 2 square minus 4 into A, which is minus 3 into C, which is again minus 1. Correct? 4 into A into C. 2 square is 4. Minus will become minus. 4 3s are basically 12. This is going to become minus 8. Oh, it is negative. And it is a downward parabola. So it will never intersect. It will never intersect. So the graph will go like this. The graph will go like this. Got it? Everyone? Pakka? So this is how you draw the quadratic graph. Now this part till here, some of you might be like, sir, I know this. Tell me more. Yes, I'm coming to more now. Now what if I give you a graph of reciprocal? Reciprocal graph, guys. Reciprocal graph. What do I mean by that? I will show you. Just observe. This is x-axis, this is y-axis, this is your origin. Reciprocal means y is equal to maybe some number by x. Basically maybe some c by x or just 1 by x. Just think of it like that, okay? C can be anything. C could be 1, 2, 3, 0.1, -1, whatever. So the moment you have that kind of graph, how will it look like? How do you think it will look like, my dear students? Understand, if this number c is positive, then you will see the graph look like this and like this. Arey, what just happened? It will look like this and it will look like this. You might be wondering, why is it going here? Why is it like that? Because when x becomes large, denominator becomes large. When denominator is large, the number becomes small. So when x becomes large, that number y becomes small. When denominator becomes small, y becomes large. So when x becomes small, y becomes large. And this is even true for the negative side. If x is negative, y is negative. Y is negative, x is negative. So where are both the coordinates negative? In the third quadrant. So that is why this is how it will be. So C is basically positive. But if C is negative, then the only difference, my dear students, will be over here. It will be in this and this quadrant. This is for C is basically a negative. Arey, what just happened? It's behaving very weirdly. C is basically negative. Is that clear? Is that clear? And this shape, you know this shape, what is this shape called as? This shape is basically your rectangular hyperbola. Which Ebola? Ebola? No, it is not Ebola. It is hyperbola. Come on guys, bola. Hyperbola, rectangular hyperbola, okay? Keep these things in mind. These graphs are particularly useful in electrostatics. How many of you are droppers? How many of you have studied electrostatics or seen my electrostatic class? You would have seen potential KQ by R. R is below. KQ is like C. So the graph looks like that only. Remember? Remember everyone? So these kind of things are useful in different places, my dear students. Awesomeness. Moving to the next graph. Okay. Now, let us take one more graph. What if I use an equation like this? Y is equal to 1 by x square. This is an unknown number. Now you have to think logically. Guys. You cannot by heart. If you sit and by heart this, gone. Gone. So, my dear students, y is equal to 1 by x square. Think logically. If x becomes large, then y will become large or small? When x becomes large, y will become large or small? Think logically. X becomes large, denominator becomes large, ratio becomes small, y becomes small. Correct? Also, if x goes a very large value on the negative side, minus infinity, x becomes very large on that side. Square of negative infinity is infinity square. Negative will cancel. Minus has no significance here. So it will again become a very large denominator. Ratio will become small. So y will again become 0. Tends to 0. Also, notice one thing. Whether x, even if it is negative or positive, y is always positive. That means the graph is never going to come down. The graph is never going to come below the x-axis. Everybody can see that. Not just that. Not just that, now you can also visualize that this graph will be curved. It will definitely be curved. So how do I draw it? X is large, y becomes very small. X is large, y becomes very small. So it will go like this. X becomes very largely negative, y also becomes very small. So I think it should go like this. Now how do I know it goes up over here? How do I know it goes up over here? Think, if x becomes very small, then y becomes very, very large. Y becomes very, very large. Hence I know the graph will look like this. So it is like folding hands. So this is like folding hands, hai na? It's like folding hands equation. So if you want to say thank you to anyone, what are you going to say? Y is equal to 1 by x square. That is your code word, guys. If you say y is equal to 1 by x square, it is like thank you very much. If you say y is equal to x square, then how will it be, guys? Oh, x square. If x square is there, then my dear students, it is a quadratic equation. It will just look like a parabola. It will look like your smile, no? So y is equal to x square will just look like your smile, yes or no, my dear warriors? Very good. Awesomeness. Moving on to the next equation. Get ready, my dear students. Exponential. Let's go to exponential functions. Exponential means, example, y is e raised to x. Y is e raised to x. Now how will this graph look like? Let me tell you. Imagine, put values. First put x equals to 0. That means e raised to 0, which is basically 1. So that is the value of y. If you put x is very large number, then y will also become a very large number. Okay, that means when x coordinate is 0, that means when your x coordinate is 0, the y coordinate is 1. So the graph definitely starts from the number 1. And then as x increases, y also increases. So the graph will go like this. Is that very, very clear, my dear warriors? Awesome. Thank you, Sundaram. And I think after this session, everybody should comment y is equal to 1 by x square. Everybody should comment. Let the students who have not seen the video get confused. What is happening to these kids? Why are they saying y is equal to 1 by x square? Hai na? Okay. Yes, you will be getting the notes later on. Now, if I tell you, draw the graph of y is equal to e raised to minus x, then you have to think, minus power means you have to take it in the denominator. 1 by e raised to x. So, my dear warriors, this is x-axis, this is y-axis, this is 0. Okay, now think, if x is 0, e raised to 0 is 1, so y will be 1 by 1, which is 1. Acha, very good. And what if x becomes very large? Then e raised to infinity is also very large, but 1 by e raised to infinity will become very small. 1 by a large number will become very small. So hence the value will start from 1. But then it starts decaying like this. This is particularly useful in capacitor, inductor, or decay constant, or radioactivity, or chemical kinetics related questions. Graphical questions, right? So this is how exponential functions behave. Everyone with me? So understand, when it is e raised to x, as x increases, y also increases. When x is 0, the value of y that I get, because any number raised to 0 is 1, the value of y I got was 1. When I put e raised to minus x, minus power means I can bring it below. Take two values, special values, put x as 0. If you put x as 0, e raised to 0 is 1, 1 by 1 is 1. So basically the graph starts from 1. But when x increases, the denominator increases. When denominator increases, the ratio decreases. So that's why it should be a decreasing function. Okay? But it will never touch the x-axis. I hope this is clear. Archie Sharma, everyone. Crazy boy, don't keep asking notes. There is no point spamming like that, okay? Everybody knows that you will be getting notes in the Telegram channel after the session is over. So don't spam. Okay, next important thing. What could it be? Trigonometric functions, my dear warriors. And let's play with trigonometric functions. So if you have to draw the graph of, let's say, for example, y is equal to sine theta. The graph will look like a speed breaker, and the speed breaker starts from 0. That means it will go up like this, come down like this, go up like this, like a speed breaker. And that speed breaker also continues here also on the reverse side. When you complete one cycle, this point will be 2 pi radians, this point will be pi radians, correct? And the maximum value is +1 and the least value is going to be -1. It goes up, comes down. Remember, sine is positive in the first quadrant and second quadrant. It is negative in the third and the fourth quadrant. So till 180 degrees it is positive. After 180 to 360 it is negative. And sine of 90 is 1. Sine of 270 is -1. Remember that this value becomes +1 at pi by 2 radians. This is pi by 2. And this value becomes -1 at which value, guys? 3 pi by 2 radians. 3 pi by 2 radians means 270 degrees. Is that okay? Very good. Similarly, if I ask you to draw the graph of cos theta, the graph of basically cos theta, my dear students, cos is like sine but a shifted speed breaker. This speed breaker started from 0. For cos, the speed breaker starts from the maximum value, then goes to 0, then minimum, then 0, then maximum, like this. This continues behind also. So basically it becomes 0 at 90 degree, that means pi by 2 radian. This value is pi radian, this value is 3 pi by 2 radian, and this value is finally 2 pi radian. It starts and comes back. So one cycle is completed and the maximum value is +1, the least value is -1. Okay, the least value is -1. Everybody with me? Very good. Next important thing, my dear students, your tan theta graph. So how will your tan theta graph look like? Tan theta, y is equal to tan theta. Guess what? This graph looks somewhat like this. It goes from 0, goes like this, then tuck, it will drop, go to -infinity, go again up and go up like this, and again drop, and again go up like this, and continues. And this continues on the reverse side also. So this is a graph of tan, and the maximum value is infinity, least value is -infinity. These dotted lines that you see, that will happen at basically 90 degrees and then 270 degrees and so on and so forth. So this is basically your pi by 2 or basically your 3 pi by 2 and stuff like that. Okay, so this is how the tan function behaves. It goes here, but it never touches this line because tan 90 is not a defined number. I have seen many students saying tan 90 is infinity. Then if you are saying that, that is wrong. Okay, because it is neither plus infinity nor minus infinity. Understand that it is not even a number. It is not a real number. It is not an imaginary number. So it is not even a number. So there is no point discussing about it. Keep this in mind. All right, very good. Now let's see the more fun part. You'll be like, okay, what can be the more fun part? Let's come to circles and so many other things, because sometimes you might need the equation of a circle. So imagine this is x-axis, this is y-axis. How many of you know the equation of a circle, guys? How many of you know the equation of a circle? The radius is basically r. Then you take any point with some x, y coordinate. then the equation is x square plus y square is equal to radius square. Yes, this is what it is. X square plus y square is r square is the equation of a circle of radius r. So imagine I tell you x square plus y square is equal to 3. Guys, can you tell me what is the radius? Guys, can you tell me what is the radius? Come on, think and tell me. Think and tell me. Very good. Yes, is the radius 3 or is it 9 or is it root 3? Understand, it is always r square on the right hand side. So technically speaking, this is root 3's square. So r is like root 3. So radius is root of 3, my dear warriors. Exactly. Very good. So that's the equation of a circle. Similarly, sometimes you might be given ellipse, especially Kepler's laws, or in SHM the velocity and the position graph is an ellipse. So let's talk about ellipse. Ellipse is like anda. It is like your egg, oval shape. So how does that look like? Say for example, I draw an ellipse like this. Beautiful ellipse. है ना? Do you know what is this line called? Do you know what is this particular line called? This line, because it is on the bigger side, it is called as the major axis. What is it called? Major axis. Now, no points to guess this. What will this line be called? Because it is on the smaller side. If this is major, this will be what? Captain, lieutenant, colonel. What, guys? Which post will it get? Obviously minor. So this is nothing but minor axis, my dear warriors. This is minor axis. Very good. This major axis is made of two equal parts. If I call this as A, even this is A. So what is the length of this total major axis, major diameter? It is A plus A, which is 2A. Similarly, on the minor side, if the upward part is B, this is also B. Total minor diameter is basically 2B. Very good. Now, the equation of such an ellipse is x square. X axis is with A, so x square by A square, plus y axis is with B, so y square by B square, and that is equal to 1. This is the equation of an ellipse. Now going back a little bit over here, we all know what is the area of a circle. The area of a circle is basically pi r square, right? It is basically pi r square, right? Do you know that there is an area of an ellipse formula? What is the area of ellipse? Very rarely you will need it, but just giving it to you. What is the area of the ellipse? It is very similar to pi r square, but you will take this radius and this radius. For a circle, both the radius are same. This radius and this radius is same. So pi r into r, right? That's for circle, but for ellipse, it is pi a into b. So pi a b. That is the answer, guys. Pi a b. Okay? Just giving you all these things just for your reference. Okay? You never know where you might need it, how you might need it, how difficult the NEET paper might come next year. Awesome. Very good. Excellent, my dear warriors. So, how about going to a software, my dear warriors, and that is called Desmos, and playing around with this. How about playing around with this, right? It will be fun to see how it works. Whatever we have drawn, we can verify it by just typing that particular equation. So say for example, I want to type the equation y is equal to 3x and then minus 2. Look at this, guys. Actually, it is a straight line and it is passing through minus 2. I hope you guys can see that. Maybe I should reverse contrast. Yep, these minor guidelines not needed. Okay, I think it should be fine. Just check this out. Can you see that? It is actually passing through -2, right? Let's change the equation, my dear warriors. And let's make it y is equal to maybe 2x square minus 3x plus 5. Just making some random equation. Obviously it is a quadratic equation. See, look at this quadratic equation. See guys, this is your x-axis, this is your quadratic equation. Do you see the constant is 5? It is actually passing through that point 5 over here. It is actually passing through that particular point 5 over here. Yep, very good. And do you see it is above the y-axis? Sorry, x-axis. So can you tell me how many roots it has? Quickly post the answer in the chat box. Yes, Capto, I will be doing J 2020, not 2023, I guess you meant 2024. Yes, I'll be doing it. Yeah, no roots, definitely no roots guys. But the moment, if I bring it down, maybe I put it as -1 or something. Just see this, now how it looks. Oh, now it has 2 roots. Okay, now it has 2 roots. You can see that it is hitting here as well as it is hitting here. Both the things are the roots. Very good. What if I draw the graph of y is equal to 1 by x? Okay, I'll be just drawing, or 2 by x. So 2 divided by x. Look at this, exactly what we were expecting it to be. See this blue colored graph? It is like that and like this. It is not touching the x-axis. If you zoom onto it, you can see there is some gap. No matter how front or how forward you go, it will never touch it guys, if you zoom onto it. Are you seeing that? So that is how that graph looks like for 2 by x. But if I make that number 2 -2, all right, we know what is going to happen. It's going to go here and it is going to go here. What a way. What a way. Very good. C is negative. I can also try some other things with this. Okay, now I can make this x as x square, and just like I told you, the thank you function, look at this. It's like it is folding hands. Exactly. 2 by x square. If I make that 2 -2, it will obviously flip down. It will be like this. Instead of this, it is like this. Like that. So that is how that function behaves guys. You can play obviously with all the functions that I have told you. Let's say for example I take e raised to x. So I think e raised to x will be somewhere here. Where is e raised to x? Exponential. Yes, EXPX, that's what it is. Okay, why is it not working? I need to check on that. Not sure why it is not working. Okay, let's see something else. Like say for example sine of x. Wow, beautiful looking function. See, starts from 0, goes up, duck, like a speed breaker, continuous speed breaker. You can change this sine to cos also, okay, and you can see how things will change. So y is equal to, let's say, cos of x. See, this is how that function looks like. It starts from 1. It basically starts from 1 and it goes down to -1. That's how it looks like. And I can also show you tan function, because many of you will be interested in tan function as well. Look at this. This is how tan of x looks like. Exactly what we were predicting it to be. Wow. Now these lines are placed very close to each other, so I'm not able to zoom, but yes, these are lines going like this, like this, like this, like this, like this. So many lines, they are not straight lines, they are curves actually. Yep. So what a beautiful way to see graphs. Now you can play around with it so much that you can draw anything, guys. You tell me some random, your weirdest dream, everything can be drawn. Say for example 5 x raised to 2 plus, let's say, cos x, all right, divided by, I don't know, x minus 4. Some random thing, guys. This is some random thing that I have drawn, and you will see how that graph looks like. Oh my god, it's squeezed, it's going down, it's taking a sharp U-turn, and it is going up, and then it is again coming down. Wow, crazy. So I can change this to something else as well. I can change this to something else as well. I can make maybe all of these things, let's say 5x divided by maybe, I don't know, 7x square minus 5. Wow, what a function, guys. Look at this. Look at this, how it goes. It's going down, then coming up, then going down like this. So you can play around with whatever you want. And please don't be limited by whatever I have shown you today. Please don't be limited by whatever I have shown you today. This is your playground. What is this, guys? This graphing software is your playground. When you go to play, do you ask, can I run here? Can I run like this? What will happen if I run fast? What will happen if I play here? No, right? It's a playground. It's open. It's an open field. You play, you enjoy, you learn. You learn from your mistakes, and then you improve. So same way, play with this. Don't just do, sir told this graph. You try your own graphs. Whatever your creativity is, you can use. Many students have been sending me, in the past few years, the crazy designs that they have made using the Desmos software. Some of them have made butterflies. Some of them have made Batman shape. Some of them have made a moving circle. Some of them have made some dancing things. So the creativity lies within you. Use it. This is your playground. And that is what today's session aimed at. It was not to teach you graphs. It was to teach you how to enjoy graphs. It was to teach you or tell you that there is no limit to this. There are no boundaries to this. So I really hope you guys have enjoyed this class today. I really hope you have learnt a lot from today's session, and hopefully you will be able to explore many more such graphs using this software too. Okay, so thank you very much. Do let me know in the comment section, and yes, do not forget to put that y is equal to 1 by x squared so that we confuse other kids. Okay, bye bye guys. Thank you for subscribing in case you haven't done that yet. And yes, there will be a discussion session of the DPP problems which is going to come up tomorrow at 5 o'clock, so do not miss that. Bye bye. This is Captain Shreyas signing off. Hasta la vista.